Okay, Algebra 2, Module 3, Lesson 3, talking about exponents. Number 1 says, write the following exponential expressions as equivalent radical expressions. There's your clue that it's going to be rooted because you're working with radicals. So 2 to the 1/2 power would actually be written as, or could be rewritten as what? Simply the square root of 2, right? So then if it is 2 to the 3/4 power, though, how would you do that? Now it's going to be the bottom whoop, that's not a real good circle there. The bottom tells you what the root is, so now it's going to be 4th rooted 2 cubed. The top, the numerator of the fraction goes inside with the base. Okay? So we could still do that and say what? The 4th root of 8. Go ahead and do it. You can still work that out, so go ahead and do it. So same thing, we're just going to do, this is going to be the cube root of 3 squared, which we can work out to be the cube root of 9. All right. Oh, wait. I think that's supposed to be a negative exponent there. It's hard to see, but I think that's supposed to be a negative exponent. So knowing that that's a negative exponent, what do you know? You know something about negative exponents. Where do those go? Number, or C there, that's supposed to be a negative 2/3. So if it's a negative exponent, where does that go? Where do negative exponents reside? I've jumped up and down for 2 days saying this. If you see a negative exponent, what does that mean? It's in the, if it's already in the denominator, it's a positive. But if you see a negative exponent, you're going to put whatever that is in the denominator. So right now, we don't have a denominator. So what are we going to do? All you got to do is just put it under 1. That's it. That negative makes it like that. It's just blowing air right now, I think. No, if you open the window or open the door, it gets cold in here, therefore it kicks back on. It will shut off. 23 is not blistering heat. No. No. All right, number 2, rewrite the following radical expressions as equivalent exponential expressions. So now you're taking the radicals and putting them in the exponent. Well, we know that that is simply the square root of 5, right? So that's going to be a simple 5 to the 1/2 power. Okay? Now, just like, we're just reversing what we did earlier. So now we have 2 times the 4th root of 3. How would we do that? 2 times the 4th root of 3. Anybody? Anybody want to take a stab at B there? Anybody? What do you mean you want to use parentheses? I don't think so. I don't think you're going to do that. You have to think about what happens when you pull something out of the radical. What have you actually done? You're going to have to put it back inside the radical based on whatever it is, right? So if it's cube rooted, you're going to have to or if it was cube rooted, here it's to the fourth, right? So we're going to have to put 2 back inside the radical and say 2 to the fourth times 3. Okay. Since it was pulled out, we got to put it back in there. Now, what is that? What's 2 to the fourth? 16. And then 16 times 3 is 48. So that's going to be the, now it's still the cube root, right? Not the cube root, fourth rooted. It's still fourth rooted, so we got to keep that in there. But now we're not wanting to leave it like that. We're trying to get to an exponent, right? So now what is your exponent going to be? 48 1/4, good. All right, so there's a little bit of work to do on those. You have to remember, if we brought it outside the radical, we got to put it back inside and do whatever the root is, okay? Now, okay. So first of all, you should know what about C? It's going to have a what exponent? Negative exponent. Good, because we have a radical in the denominator, and it's rooted, or it's cube rooted, so we know that we're going to have something to a negative power. Now, what is that going to be? 16 to the what? Negative. Negative 1/3. Right? Because it's cube rooted. Everybody good with that? All right, page 2. This was a long exit ticket. Provide a written explanation for each question below. Is it true that 1,000 to the 1/3 power to the third power is equal to 1,000 to the third times to the 1/3 power? Is that true? Think about your exponent rules. Is it true? Anybody? They want to take a stab at that? Yeah, it is, because if you think about your exponent rules, and you have an exponent raised to an exponent, what do? You just multiply them together, right? So it doesn't matter if you're doing 1,000 to the third to the 1/3 power. You're going to just multiply those together. So if you multiply 1/3 times 3, either way, it's going to end up being what? What's 1,000 to, what is 1/3 times 3? 1, right? So both of those are going to equal 1,000. Okay. B says, is it true that 4 to the 1/2 power to the third power is equal to 4 to the third power to the 1/2 power? Same thing, right? If you know your exponent rules, if it's an exponent raised to an exponent, we just multiply those. Well, that's not fun. What is 4? So that would be the square root of 4 to the third is equal to the square root of 4 to the third. Is that right? So what's 4 to the third? 4 times 4 is 16 times 4 is 64? Is that right? Oh, well, we can do that. Both of those are going to equal 8. Better check this. Yeah, both of those are going to equal 8. So that is true. Those are true statements. C says, suppose that m and n are positive integers and b is a real number so that the principal nth root of b exists. In general, does or do those two equal each other? Yeah, that's what we've been doing this whole time, right? In general, those are going to work together. So we could say b to the 1n to the m. If we were to do that, that would equal b m over n, right? And we could rewrite that as b m to the 1n. It's the same thing, just divided. All right.